Welcome to the Plugins and Semantic Kernel course by Simplilearn. In this course, we will understand and get hands-on open source semantic kernel, then we will build some kernel functions to summarize some text and do the usual things like chaining. Then we will jump to design thinking, where we collect customer feedback and stick into the plugin and get it to do things and generate the magic of AI. Then we are going to apply SWOT analysis to the small business thinking AI plugin to find ways to improve the cost and the time efficiency. Then moving forward, we will understand the vector memory and how to store the functions for future use. Now moving on, we will understand why plugins are useful in leveraging the small businesses. Then we will understand the business memory with embeddings. And lastly, but not the least, we will understand how to unlock the power of plugins in Semantic Kernel. By the end of this course, you will not only understand how AI can enhance business operations, but also how to implement it practically using the Semantic Kernel plugins. So let's understand what a semantic kernel actually is. Imagine you are building an AI-powered assistant that can write emails, summarize documents, and even book appointments for you. But instead of hard coding every possible task, what if you had a brain-like system that could intelligently reason, plan, and generate responses based on the context? That's where semantic kernel comes in. So a semantic kernel is an open source AI SDK developed by Microsoft. It acts as a bridge between AI models, that is the GPT-4 and DALL-E or other LLMs, and the traditional software applications. Think of it as an AI-powered middleware that helps integrate natural language processing, reasoning, and planning into apps effortlessly. Now, after we have understood what is a semantic kernel, let's understand why it is called semantic. The word semantic refers to the meaning and understanding in language and context. The traditional software runs based on the predefined rules and logic, but semantic kernel enables applications to understand the meaning and generate responses dynamically based on the context. For example, a normal chatbot may answer, "I don't understand that question," if it doesn't find a predefined response. But a semantic-powered chatbot using the semantic kernel can interpret the intent behind the question, retrieve the relevant knowledge, and generate an appropriate response, making it more intelligent. Now let us understand where and why is semantic kernel used. A semantic kernel is widely used in the AI-driven applications, especially where the context-aware reasoning, decision-making, and automation are required. So here's where it shines. The first is AI-powered personal assistants. Used in chatbots, virtual assistants like Microsoft Copilot and AI agents that need to process natural language comments and text actions dynamically. Then comes automating business processes. Imagine a customer support AI that can not only respond to the queries but also generate reports and documents and schedule meetings intelligently. Now moving to the third one, we have context-aware applications. It enhances apps that require dynamic responses such as the AI-powered email assistants, coding copilots, or content summarizations. Now moving on to the fourth one, we have integration of LLMs with the traditional software. So developers can embed AI functionalities into existing enterprise software like the CRM, ERP, and project management tools without rewriting the entire application. Now moving to the fifth one, we have AI workflow automation. It helps in chaining the multiple AI tasks together, like the step 1, summarizing a report. Then step 2 comes extracting the action points. Now the step 3 comes drafting an email based on those points. Then moving to the fourth one, we have scheduling a meeting based on the discussion. Now, after we have understood where and why is semantic kernel used, let us understand how does semantic kernel work. At its core, the semantic kernel enables developers to orchestrate and combine the AI model plugins and memory storage into a unified system. It consists of planners, It helps decide what to do next. For example, a chatbot figuring out whether to reply or schedule a call or summarize a document. Then moving on, we have plugins, that is the small modular functions that perform the specific task like calling an API or retrieving a data. Then we have memory that allows the AI to retain the past interactions and use that context for the smarter responses. So Semantic Kernel is a game changer in the AI-powered application development. So instead of treating AI as a mere tool that responds to the queries, it helps developers build AI systems that can think, reason, and act contextually. So whether you are building chatbots, automation tools, or AI-driven business applications, Semantic Kernel simplifies the AI integration, making apps more intelligent, responsive, and human-like. So after understanding this theoretically, let us see all this in hands-on. So here in the first sentence, we have actually imported or loaded the Semantic Kernel library, which helps us interact with the AI models. Then from the Semantic Kernel.connectors.ai OpenAI import Azure Chat Completion and OpenAI Chat Completion. It is basically importing two classes. The Azure Chat Completion. What is it used for? It is used when integrating with the Azure OpenAI, Microsoft's cloud-based version of OpenAI. Then OpenAI Chat Completion. This is basically used when connecting to the OpenAI's API directly. These classes allows us to use the AI-powered text completion. That is, for example, the chatbots, AI assistants, and automation. Then kernel is equal to sk.kernel. It basically creates a new instance of the semantic kernel. Think of this as an AI brain that can be trained, given task, and connected to the OpenAI models. Then user Azure OpenAI. This is a flag basically, so true or false may be the value that determines which AI provider we want to use. If set to true, the script will use Azure OpenAI. If false, it will use the OpenAI's standard API. If use Azure OpenAI, it checks if use Azure OpenAI is true. If so, it connects to the Azure OpenAI. Then deployment API key endpoint is equal to sk Azure OpenAI settings from .env. This basically retrieves the Azure OpenAI settings, that is the API key, endpoint, deployment ID from an .env file, that is the environment variables. This keeps the API keys safe instead of hard coding them in the script. Then it adds the Azure OpenAI's chat completion service to the kernel. This means the kernel can now generate the AI-based responses using the Azure OpenAI. Then it is there else API key. This basically runs if use Azure OpenAI is false, meaning we want to use the OpenAI instead of Azure. So API key org ID is equal to sk.openai settings from .env. This basically retrieves the OpenAI API settings, that is the API key and the organization ID from the .env file. Then kernel.add.text collection service. This is basically adds the OpenAI's text collection service to the kernel using GPT 3.5 Turbo. This means the kernel will now use OpenAI's chatbot capabilities to process and generate text. Then we will print here, basically print, we'll give one bracket and we'll start with you made a kernel, so that I can receive this text and basically understand that actually I made it. So let's run this. Here we are basically importing the semantic kernel library, which helps the integrate AI models into applications. So it imports the Hugging Face AI model connector for text generation. Then Hugging Face, if you are not aware, it's an open source AI model hub that provides the free models like GPT-2, BERT, and others. Then we have kernel is equal to sk.kernel. Basically, it creates an instance of the semantic kernel. Think of this as a brain that can process and generate the AI-powered text. So kernel.add add underscore text underscore completion underscore service Hugging Face. This means it registers an AI-powered text generation service under the name of Hugging Face. This means that later in the code, we can ask the kernel to generate the text using this model. So, Hugging Face basically uses the GPT-2 model from Hugging Face. Task is equal to task generation. That is, it specifies that this AI model should be used for text completion like writing paragraphs or chatbot responses. Then basically we have printed, you made an open source kernel using an open source AI model. So this prints a success message to let the user know that the AI kernel is set up correctly. So it highlights that both Semantic Kernel and GPT-2 are open source, making this a completely free and customizable AI setup. So let's run this. So you can basically see that is downloading and we have to wait for some time, and it is a success. You made an open source kernel using an open source AI model. So down the line, we will understand about the plugins in Semantic Kernel. The rise of artificial intelligence and large language models is changing the game. But simply using AI is not enough. Businesses need a structured way to integrate AI into their workflows, making tasks more efficient and intelligent. This is where Semantic Kernel comes in, a powerful open source framework designed to bridge traditional businesses operations with the AI-driven automation. But how do we make AI work for specific business needs? That's where plugins in Semantic Kernel become essential. So let's understand what are plugins in Semantic Kernel. Think of plugins in Semantic Kernel as smart assistants that help LLMs interact with the external systems, retrieve data, and automate repetitive tasks. They allow businesses to extend the capabilities of AI beyond answering questions. With plugins, AI can automate customer interactions, that is, the chatbots, email responses, and appointment scheduling. Then it retrieves and analyzes business data, for example, sales trends, inventory levels, customer insights. Then moving on, it can also connect with the third-party tools like the CRM, e-commerce platforms, and payment gateways. Then it can enhance the decision making by providing the real-time insights and recommendations. So these plugins act like specialized functions that help AI more than just a language tool. It becomes an actionable problem solver for the small businesses. Now moving on, we'll understand why do small businesses need plugins. So traditionally, small businesses rely only on the manual processes and spreadsheets, and intuition to operate. So however, with LLMs powered by the Semantic Kernel, businesses can automate repetitive tasks, free up time by letting AI handle the scheduling, data entry, and reports. Then it can now enhance customer experience like the offer personalized AI-driven interactions that scale effortlessly. Then get better insights, that is, use AI to analyze the customer behavior, sales trends, and business metrics. Then it can stay competitive. Even small businesses can leverage AI to compete with the larger players by operating smarter and not harder. So let's move on to the next chapter. Imagine you are having a conversation with a smart assistant like ChatGPT. You ask it, "What is the weather like today?" It understands your question, processes the meaning behind your words, and gives you a relevant answer. So this ability to comprehend, process, and respond to meaning is what semantic functions are all about. So now let's understand what are semantic functions. So semantic functions refer to the ability of a system like an AI model, a database, or a programming language to understand the meaning of words, sentences, or queries rather than just processing them as a raw text or a code. It helps in understanding the context, knowing that the apple can mean a fruit or a tech company depending on how it's used. Then it is interpreting the queries, recognizing that how's the weather and tell me the 2 days forecast mean the same thing. Then it also generating meaningful responses, not just retrieving information but representing it in a way that makes sense.
Now let us understand how semantic functions work. They rely on the natural language processing, that is the NLP, AI models and advanced algorithms to break down a sentence, that is identifying the words, phrases and the sentence structure. Then it analyzes the meaning using the language models and context to understand the intent. Then it finds the relevant information, that is like searching databases, documents or the knowledge bases. Then it responds in a meaningful way, that is generating the human-like answers. Now let us understand with the help of an example of the semantic functions in action. Let's say you have a chatbot that helps users find restaurants. Now, with the traditional keyword-based search, there is no semantics. User will write like find a cheap Italian restaurant. The system will answer only searches for the cheap plus Italian without understanding the intent. It might miss the relevant results. Now, with the semantic search, that is with the semantic functions, the user may ask like find a budget-friendly Italian restaurant. The system understands that budget-friendly is equal to cheap and provides the results that match the intent. Now let us understand what is a native function. A native function is a function that is built into a programming language or a runtime environment. Additionally, it is written in a low-level language, that is like C or C++, and runs directly on the system without requiring the interpretation. Native functions are typically a part of the language's standard library and provide the core functionalities like file handling, string manipulation, and system-level operations. Now moving on, we'll understand the difference between native and the semantic function. So here is the difference. Now differentiating them on the basis of definition. So native functions are built in the function provided by the programming language, and the semantic functions are the user-defined function created to improve the code readability. Now moving on, differentiating them on the basis of implementation. So native functions are written in the low-level languages like C or C++ and compiled into machine code. But in semantic functions are written in a high-level languages like Python, Java or JavaScript. Then differentiating them on the basis of performance. So native functions are faster because they execute directly on the system. So semantic functions are slightly lower since they are user-defined. Now differentiating them on the basis of purpose. So native functions provides the core functionalities like math operations, string handling and input-output. And semantic functions adds meaningful functionality to improve readability and maintainability of the code. Then features are based on dependency. So native functions exist within the standard library of a programming language, and semantic functions are created by the developers to define the custom logic. Now moving on, we have another two differences. Now differentiating them with the feature of readability. So native functions names are often generic like the length, the SQRT and the print. Now moving on to the semantic functions, the names are descriptive and meaningful like calculate salary, fetch user data. Now ending it with examples in Python, native functions like print, length, type and math.sqrt, and semantic functions are calculate _ discount, is _ adult, validate _ email. Now let's see all this in action. So here we are initially importing the semantic kernel as SK. So basically it imports the Microsoft Semantic Kernel library which is used for the AI powered applications as we know it earlier. So Azure Chat Completion and OpenAI Chat Completion, these are the AI model connectors that allow interaction with the OpenAI models hosted either on Azure OpenAI or OpenAI API. So then display and markdown from IPython allows displaying the markdown content inside a Jupyter notebook. Though it's not explicitly used in the script, but then we are using kernel is equal to sk.kernel. So this basically creates an instance of the kernel, which acts as the central processing unit for managing the AI services and executing the AI-driven task. So use Azure OpenAI is equal to false. This is basically a flag which determines whether to use the Azure OpenAI or OpenAI's API directly. Setting use Azure OpenAI is equal to false means the script will use OpenAI API instead of Azure. So Azure OpenAI is a service name for reference inside the kernel. So if use Azure OpenAI is equal to false, it retrieves the OpenAI API credentials from a .env file. So API key is the OpenAI API key and org ID is basically the OpenAI organization ID. So OpenAI is a service name used for the text completion inside the kernel. And then finally, we are printing a kernel is now ready. So let's run this. And this is a simple print that prints a confirmation message once the kernel is set up successfully. Let's now move on. This first 3 sentences basically defines a prompt template that will be used by the AI model. So the $input is basically a placeholder for user input, that is the text that needs summarization. The AI model is instructed to summarize the given input in less than 140 characters. Kernel.create semantic function that creates an AI-powered function inside the semantic kernel that will process the text using the defined prompt. Then there are a few arguments that are prompts template is equal to skprompt that uses the defined prompt as input for AI. Then description is equal to summarizes the input to length of an old tweet. This basically provides a human readable description for the function. Then the max tokens is equal to 200. So this is what limits the AI model's response to 200 tokens. So each token is roughly a word or a part of a word. So then we have described that temperature is equal to 0.1, which basically controls the randomness. Lower value, that is example 0.1, is equal to more deterministic output. Then higher value, for example 0.9, would be more creative and random output. Then we have created top_p is equal to 0.5. This basically controls the probability distribution for AI's word selection. So the lower values, for example 0.5, AI picks words from a narrower, more predictable set. Then higher values, for example 1, the AI picks words from a wider set, increasing the randomness. Then basically we have printed a semantic function for summarization has been registered. So we'll run this, and this print statement basically confirms that the function has been successfully created and is ready for use. Then we have this long input where we have given 2 paragraphs in this, and the explanation, I will really explain this code. Don't worry. The sk input variable stores a paragraph of text, a transcript from the TED Talk by Andrew. So this text is about how AI can help the small businesses by identifying patterns in data, using a pizza store or a small business as an example. So kernel.run_async basically calls an AI-based function that is a summary function asynchronously. It takes the sk input as input and generates a summarized version of the text. So await is used because the function runs asynchronously, meaning it doesn't block the program while waiting for the result. Then display markdown, there is some text in between, formats the output using markdown are basically a way to style the text. Then hashtags are there, adds a heading and an emoji before the summary result. So then finally we have this str summary result, which ensures the AI generated summary is properly displayed. So I'll run this and you can now see the output. Now let's actually see the display. Now in 2 ways you can actually see the result out of it, and let's now move on to the native functions. So now this must be a lot of code, but yeah, I'll explain what I'm gonna do in this. So the first one from the semantic kernel.skill definition and import. This imports the functions used to define AI skills in the Microsoft Semantic Kernel framework. Then comes the class exotic language plugin. This class is a custom plugin that contains a method for converting the words to the Pig Latin, that is a playful language transformation. Then we are defining the word to Pig Latin, that is a self word, and then we are creating a for and else one. So this function converts a single word into Pig Latin. So if a word basically starts with a vowel A, E, I, O, U, it adds the way to the end. For example, apple would be apple way. So if a word starts with a consonant, it moves all the consonants before the first vowel to the end and adds AY. For example, banana would be ananabe. So if the word has no vowels, it just adds AY. So now moving down, @sk_functions, this basically marks the function as a semantic kernel skill. So it processes a full sentence calling word to pig Latin for each word. Then there is word is equal to sentence dot split, pig Latin words equal to a blank bracket, and this basically splits the sentence into words, converts each word to the pig Latin, and then joins them back into a sentence. Then comes exotic language plugin kernel.import _skill exotic language. So this imports the plugin into the semantic kernel framework. So it can be used as an AI skill. So it basically retrieves the pig Latin function from the plugin. Then we are basically printing. This is kind of not going to feel awesome, but no, this is a big deal. So this does not call the pig Latin function. It just prints a normal sentence. So let's run this. So here basically kernel.async is used to execute the multiple functions asynchronously. So the functions, that is a summary function and the pig Latin function. So the summary function basically summarizes the input text, that is the sk_input. Then pig Latin function, it basically converts the text to pig Latin. So the input text, that is the sk input, is passed to both the functions. Summary functions generates a shortened version of the text, but the pig Latin function converts the text into pig Latin. So the await keyword ensures both the functions run without blocking other tasks. So let's now see the output. Now down the line, we are going to see a new topic.
Understanding how to organize the tools is so important. But before that, we will understand why our native and semantic functions are so important. So, native functions and semantic functions are both essential because they serve different purposes. Here are some. Native functions are built into programming languages and run fast because they interact directly with the system. For example, the file operations and the maths calculations. They are predictable and efficient. On the other hand, semantic functions focus on understanding the meaning and the context, making them useful for the AI tasks like the language processing and decision making. For example, the chatbots, then the sentiment analysis. Then large language models like the LLMs rely on semantic functions to process the text, generate responses, and understand the user intent. While native functions handle the precise computations, semantic functions and LLMs help interpret the complex human-like input. Together, they make software both powerful and intelligent. Now let us understand how they can be stored for future use. How to store native functions we will talk about initially. So storing native functions like the code files and the modules. So native functions are stored as separate code files or the modules based on their functionality. This keeps them organized and easy to maintain. Now the question comes where it is stored. They are saved in the files like .py, that is for the Python, .java, that is a Java file, or .c file, that is a C file. Grouping similar functions together, that is stored related functions in separate files. Then use modules or libraries like in Python, storing functions in .py files and import them when needed. Then comes the semantic functions. So packaging semantic functions for the easy to use. So semantic functions which use the AI, ML, NLP, etc. can be packaged into reusable components instead of just storing them as a raw code file. This makes them easier to share and integrate into different projects. Now we will understand what is semantic completion. AI that finishes your sentence. Imagine texting your friend and your phone predicts the next word or the phrase based on what you mean, not just random words. That's semantic completion. It helps AI understand the context and complete sentences in a meaningful way. So the next question comes, where is it used? It is used in the AI chatbots like the ChatGPT. It is used in the smart search engines like the Google and the YouTube. Then it is used as a coding assistant like the GitHub Copilot and the IntelliSense. Now moving on to semantic similarity. It is that AI that understands your meaning. Have you ever said something in a different way but meant the same thing? Semantic similarity helps AI recognize that two different sentences can have the same meaning. Now the question comes where it is used. It is used in search engine, that is the Google finds related info. Then it is used as AI chatbots, that is understanding what users mean. It is also used in plagiarism checkers, that is detecting the similar content even when rewarded. So now we will see all this in action. So after we understand how to actually organize the tools and store them, it is necessary to understand how these business leaders start developing AI plugins using the semantic kernel. For that, we will need to understand what is design thinking. So design thinking is a human-centered iterative problem-solving approach that focuses on understanding users, challenging assumptions, and creating innovative solutions. It is widely used in product development, UX/UI design, business strategy, and the AI-driven applications. Now comes the 5-step design thinking process includes. It includes empathize, that is understanding the user's needs, emotions, and challenges through research, interviews, and observations. Next comes define. It clearly articulates the problem statement by synthesizing the insights gathered in the empathize phase. Now moving on to the third one, we have ideate. It is brainstorming the creative solutions, encouraging the diverse perspectives, and explore multiple possibilities. Now moving on, we have prototype. Develop low fidelity or high fidelity models to visualize and test the ideas quickly. Now moving on, we have test, that is gathering the user feedback, refine the solution, and iterate until the best possible outcome is achieved. So this process fosters innovation, collaboration, and user-centric solutions in the business, technology, and AI applications. Now moving on, we will understand why are plugins so important, reasons why plugins are important, like the ChatGPT, Binge AI, MS Copilot examples, and so on. So plugins extend the capabilities of software and AI tools, enabling them to integrate, automate, and enhance user experience without modifying the core system. So in AI-powered solutions like ChatGPT, Bing AI, and Microsoft Copilot, plugins make these tools more powerful by adding the real-time data access, workflow automation, and business integration. So now moving on to the first reason why plugins are so important. It is extend the AI capabilities beyond the basic functions. So plugins allow AI models to interact with the real-world data and services instead of being limited to the pre-trained knowledge. For example, ChatGPT plugins enable real-time browsing, code execution, and data retrieval for the up-to-date responses. Now moving on, we will understand how to improve business automation and productivity. So AI plugins help professionals automate repetitive tasks like content generation, summarization, and report creation. For example, Microsoft Copilot integrates with the Office apps like Excel, Word, and Teams to automate the emails, generate reports, and provide the real-time suggestions. So now moving on, we will understand how it enables seamless integration with external tools. So businesses can connect AI models with CRM, databases, and SaaS platforms using plugins. For example, Bing AI integrates with the Microsoft Edge, Windows 11, and search tools to provide the real-time web insights and enhanced search experiences. So now moving on, we will understand how it enhances the search and decision making with AI. So AI-powered plugins fetch the latest data from the web, analyze the trends, and help in making the informed decisions. For example, Bing AI uses real-time internet access to provide the live search results unlike traditional static AI models. So now, next we'll understand personalization and customization for different users. Plugins allow users to customize their AI experience based on needs, whether for business analytics, writing assistance, or coding. For example, ChatGPT plugins integrate with platforms like Zapier to automate the workflows between apps like Slack, Gmail, and Notion. Then next we'll understand how accelerating AI adoption for the non-tech users. So AI plugins simplify complex processes, making AI more accessible to the non-developers. For example, Microsoft Copilot in PowerPoint automatically generates presentation slides from the raw text input and reducing manual effort. Now we will understand all this in action, how it is done.
So now, once again, we are back. We are making one kernel. So Semantic Kernel, basically this is Microsoft Semantic Kernel, which helps integrate the AI models like the GPT 3.5 Turbo into applications. Then Azure Chat Completion, OpenAI Chat Completion, these are basically classes that allow the kernel to connect with the Azure OpenAI or OpenAI's ChatGPT. Display, Markdown, these are basically used for displaying the formatted text output into Jupyter notebooks. Then we have kernel is equal to sk.kernel. So kernel is like a central controller that handles the interactions with the AI models. So this kernel instance will later be connected to the OpenAI or the Azure OpenAI. Then we have use Azure OpenAI is equal to false. So since use Azure OpenAI is equal to false, this part connects to the OpenAI's GPT model. Then we have steps to perform. That is, it loads the OpenAI API key and organization ID from the env file. Then it adds the OpenAI's GPT 3.5 Turbo as the AI model for the text generation. Then finally, we are printing a statement the kernel is now ready and we will run this. So this simply prints a message indicating that the semantic kernel is set up and ready to be processed the AI-based text generation. Now let's move on. So here basically we have imported the JSON library which is used for handling the structured data like the customer feedback analysis results. Then we have this plugins directory, that is .pluginssk. So it points to the directory whether the semantic kernel plugin for the design thinking is located. Then we have strengths, then weaknesses, then opportunities, then threats, and so on. So strengths, weaknesses, opportunities, and threats, that is a SWOT. This list represents the predefined answers for each category of the SWOT analysis. So the goal is to access what is good, what could be improved, and what opportunities to exploit, and the external threats. Then we have a list of customer comments, and this is a set of customer feedback which includes the complaints, compliments, and the questions related to the pizza shop. So these questions will be analyzed to gather insights about what customers think. Then we have one plugin DT. That is the kernel.import semantic skill for directory. Then this line actually loads the design thinking plugin from the plugins SK directory. The design thinking framework helps in empathizing with customers, defining problems, brainstorming ideas, creating prototypes, and testing solutions. Then we have my result is equal to await kernel.run underscore async, and then we have plugin DT, empathize, and everything. So the customer comments are passed to the empathize phase as input. Then run underscore async, this function basically runs the operation asynchronously, meaning the code continuously works without waiting for the result. It allows the faster execution, especially when waiting for the external AI processing. Then we have the display markdown, and this formats the output in markdown and displays it in a Jupyter notebook. It provides a heading with some styling indicating that the results are from the empathize phase. We are basically printing my result from the empathize phase is returned as a JSON string. then str my result. This basically converts the result into a string format. Then we have JSON.loads, which converts the string into a JSON object. Then we have JSON.dumps, that is formatting the JSON object into a nicely indented format for better readability. Indent is equal to 2 means a 2-space indentation. This will print the categorized observations such as the pain points, feelings or insights from the customers in an easy to read format. So we'll run this. Now we are getting all this, and now let's move on. So here kernel.runAsync runs an AI function asynchronously without blocking the execution. The plugin DT empathize. This triggers the empathize phase where AI reads the customer feedback and categorizes it into different themes, for example, complaints, praises and suggestions. Then we have plugin DT that is equal to define. This follows up with the define phase where AI takes the categorized observations and identifies the core problems faced by the business. Then we have input underscore str. This is equal to customer underscore comments. This customer comments are passed as input for AI to analyze. Then we have display markdown. Then we have this formats, basically the output in markdown for a nicely structured display. Then the categorized observations from the empathize is within this bracket and with this hashtag. And then we have this empathize, then define phases or of design thinking. This basically creates a bold heading that adds empathize. Then str my result converts the AI structured response into a readable text format. So we'll run this. So now we are getting the categorized observations from the empathize plus define phases of design thinking. We are getting the analysis, the definition and the possible source. But have to keep one thing in mind that LLMs does not always provide the same results. So the result you are seeing in this video may differ from what actually you are typing. So let's move on. So here we are having my result await kernel.async just as previous. So it runs with the 4 AI powered steps of the design thinking process. The empathize, define, ideate and prototype with paper. So empathize, this is basically AI analyzes the customer feedback and categorizes it. For example, complaints, praises or suggestions. Then we have define, that is AI identifies the key problems and the business challenges based on feedback. Then we have ideate, that AI brainstorms the creative solutions to solve the identified problems. Then we have prototype with paper, that is AI creates a conceptual prototype, a basic plan or sketch of the solution. How does this work? So AI reads the customer feedback from the customer comments. It processes insights and sequentially using the design thinking steps. The result contains a structured observations, problems, solutions, and a prototype draft. Then we have the last sentence. This is actually displaying the AI generated observations, problem definitions, solution ideas, and prototype concepts in the markdown format for a structured view. So this basically hashtag and then one emoji basically creates a bold heading to indicate the design thinking insights, and this lastly str my result, this converts the AI results into a readable text format. So we'll run this and we're getting this. Here basically in the code, the first line, the escape prompt is equal to they are given an experience like. Then summarizing their possible reactions to this experience. Till this, we have, this is basically a prompt template that sets up a situation for the AI. So it describes a character, a tired and a frustrated 40-year-old man. The AI will receive an experience, for example, getting a loyalty card and predicting how the man reacts. Then we have dollar input. That is basically a placeholder where a real scenario like getting a loyalty card will be inserted later. Then we have this text function, kernel.create, semantic function. So what does this basically do? It creates an AI function that will take an input experience and predict the reaction. There are certain parameters with it, that is the prompt template that is equal to sk underscore prompt. It uses the scenario we defined above. Then we have description. That is a simple explanation of what the function does. Then we have max tokens is equal to 1000. It basically limits the AI response length. Then we have temperature. That is 0.1. It is a low temperature, low randomness. Then the AI will give more predictable answers. Then we have top underscore b, that is equal to 0.5. It controls how diverse the responses can be. It balances the creativity and accuracy. Then we again have one input, and it defines an experience whether the bird gives every customer a loyalty card with the reward details. Then we have test result is equal to await kernel, and basically we are passing this test function and the input. Then it runs the AI function, that is a test function, with the loyalty card experience as input. So the AI will predict how the tired, frustrated man react to receiving a loyalty card. Then basically displays the AI generated reaction in the markdown format for a better readability. The AI's response will predict different ways the man might react. So we will run this. The 40-year-old man may initially be skeptical or indifferent towards the loyalty card, especially if he is in a bad mood. However, as he reads through the details and realizes the potential rewards and the benefits of earning points, he may become more interested and motivated to participate. He may see it as a way to save money or receive perks for his loyalty to the bar. So overall, he may feel more positive and engaged with the bar's loyalty program, potentially improving. So now down the line, we will see how AI-powered business memory with the embeddings. So before we start coding, think about this. What if LLMs could remember, refine, and reuse the past completions instead of starting from the scratch every time? Using embeddings, we can store generated content, search for relevant insights, and dynamically retrieve the best responses. So this turns LLMs into intelligent AI partners, not just assistants. Now, let's build it. So, initially, we are importing the necessary libraries. The IPython's display is just for formatting, and then we have the Semantic Kernel, SK, helps us work with the AI models. Then we create a kernel which acts as the central hub for our AI operations. We load our OpenAI API key and the organization ID from a .env file so we can securely connect to the OpenAI services. Now, after that, we attach the two services to the kernel. The text completion service, this lets us use the GPT 3.5 Turbo to generate the text. Then we have embedding service. This converts the text into embeddings, which are numerical representations that help us store and search for the relevant information efficiently. Lastly, we set up the Chroma as a memory store, which acts like a database where we can save and retrieve the AI-generated content. Since it's persistent, the stored data remains even after stopping the script. In short, we are setting up a system where AI can generate the responses, store useful data, and retrieve the relevant information when needed, making it smarter over time. Now, let's run this and move on to the next one. Now, after running this is basically a piece of code which is about the managing the stored AI memory. So first we import the shuttle, a Python module that helps with the file operations like deleting directories. Then we define a flag called the delete directory. If it's set to true, the script will delete the existing memory storage before setting up a fresh one. So inside the if block, if we specify the directory path, that is the my memories, where our AI's memory is stored, using shuttle.rm3 directory path, we completely remove this directory, erasing all the stored embeddings and the past interactions. So after that, we re-register Chroma as the memory stored, ensuring it starts fresh with an empty storage. Finally, it prints a warning message letting us know that the memory has been reset. If the delete directory is false, the script keeps all the stored data and doesn't delete anything. This is useful when we want our AI to retain the previous interactions instead of starting over. Then we will run this and basically move on. Yes, then it says SWOT analysis. So this code is all about storing a SWOT analysis for a pizza shop using the AI memory. It helps the AI remember the key strengths, weaknesses, opportunities, and threats so that it can provide the context-aware insights instead of generating random responses. So firstly, we define a set of questions and answers for each category. For example, the strengths might include things like a unique garlic pizza recipe or a prime location near a university. Weaknesses could be high staff turnover or negative reviews from the younger customers. Then we have opportunities focused on the new ways to grow, like expanding catering services or leveraging the local startups. And threats highlight the external risks such as rising the cheese cost or nearby street construction affecting the foot traffic. Next, we define the SWOT as our memory collection name, meaning all this data will be stored under one level for the easy retrieval. Then we loop through each category and save the information in the memory using embeddings. Each entry is stored as Q&A pairs so that the AI knows both the question and the best possible answer. So this code is all about searching for the relevant information in our stored AI memory using embeddings. Instead of just generating a response from the scratch, it looks for the previously stored insights that match the question. First, we define the potential question, which is the query we want to search for in this case. What are the easiest ways to make more money? Then we initialize a counter to keep the track of how many results we find. Next, we use the kernel.memory.search async to search the memory store, that is the memory collection name is equal to SWOT for similar stored information. We set a limit of 5 results, meaning the AI will turn up to 5 relevant answers. The mean relevance score is equal to 0.5, which ensures we only get results that are at least 50% relevant, filtering out the weak matches. Then we display the question in markdown format to make it look more structured. So after that, we loop through the search results. The first matching memory, the most relevant one, is stored in the related memory. Each result is then printed with its ID and the stored text and the similarity score, so we can see how well it matches the query. So now let's run this. So as explained, this is what is that potential question, and I have actually run this and you can see the result. Potential question, what are the easiest ways to make money? Result 1, 2, 3, 4 and 5 only, because we have restricted it till 5. So now let's move on. Then we have what if scenario. How can the business owner save time? So this code is all about the retrieving relevant business insights and turning them into a human readable presentation. So instead of making the AI generate response blindly, it searches the stored knowledge to find the best matches for the question. How can the business owner save time? So first, we define what if scenario as our query. Then we search the memory store, that is a memory collection name we have used as SWOT, to find up to 3 highly relevant responses with at least 77% of relevance. This ensures we only get high quality matches. Once the matches are found, we print a confirmation and store the most relevant memory in related memory. All matching responses are collected in gathered context so that can be used later. Next, we load a pre-built AI skill called the friendly consultant from the ./plugins_sk directory. This skill is responsible for turning the raw AI insights into a business-friendly presentation. Finally, we set up a context with the original question and the retrieved insights. Then the AI synthesizes everything into a well-structured presentation using the presentation function from the plugin. The result is displayed as a formatted markdown document, making it look clean and professional. So we will run this. This is the generated presentation. So basically, in this chapter, we have unlocked the RAG, that is a retrieval augmented generation, in the kernel. And then in the next chapter, we will see how to unlock the power of plugins in the semantic kernel. So before we begin, just think, what if your AI could do more than just suggesting the recipes when you are hungry? So instead of simply generating text, it could connect to plugins, check restaurant availability, place an order, or even schedule the meal preparation. This is where LLMs with plugins come in. They don't just provide information, they interact with the external systems, retrieve real-time data, and take action. So whether it's booking a table, ordering groceries, or managing your diet plan, the AI becomes a true assistant that does things for you, not just things for you. So let's see how this works in action. Now we have all these codes, and don't worry, I want to explain it line by line. So this code basically sets up an AI-powered semantic kernel that can generate text and processes embeddings using either OpenAI's API or Azure's OpenAI services. It first imports the necessary modules, including tools for the chat completion and text embeddings, which allow the AI to generate responses and convert the text into vector representations. A kernel is then created to manage this AI task. The script includes a toggle, that is a use Azure OpenAI, which determines whether to use the Azure's OpenAI services or OpenAI's own API. If set to true, the kernel loads Azure OpenAI settings from a .env file and registers the Azure's text generation and embedding services. So otherwise, it defaults to OpenAI's GPT 3.5 Turbo and text embedding ADA 002. So this flexibility allows seamless switching between different AI providers based on the setup. So finally, the script prints "I did it, boss" as a confirmation that everything is working. So this setup is useful for AI applications that require both text generation and memory capabilities, enabling the model to retrieve and process information dynamically. So let's now just run this. So this code enhances the AI kernel by adding the tools that allow it to perform the maths operations, handle files, manage time, and manipulate text. So first, we create an action planner, that is action planner kernel, that helps the AI decide which actions to take when handling tasks. Then we import several built-in skills from the semantic kernel. The math skill that enables the AI to perform the calculations. Then file IO skill that it lets the AI read and write files, making it useful for handling the documents or saving data. Then we have time skill that allows the AI to fetch the current time or work with timestamps. Then we have test skill that provides the tools for processing and manipulating the text. So each of the skills is imported into the kernel using the kernel.import skill, making them available for use. Finally, the script prints a message confirming that these tools are now added, meaning the AI can now do maths, handle files, checks the time, and even processes the text dynamically. Then now let's run this. So here, this code is making the AI figure out the best function to solve a given problem, in this case, adding 110 and 990. So first we ask, what is the question? What is the sum of 110 and 990? Then we print a message indicating that the AI is searching for the most relevant function to complete this task. Next, we use planner.createPlan _async. The goal is equal to ask, which tells the AI to analyze the question and determine the best skill or function to use. The planner looks at all the available skills like the math, file IO, time, and text, and selects the most relevant one. Finally, the script prints the best match in the format that is a skill name dot function name, and showing which function the AI has chosen to get the job done. This makes the AI intelligent enough to pick the right tool for different types of tasks dynamically. So here again, this code helps the AI find the best function to answer the question, what is today? So first we define the ask with the query, then we print a message indicating that the AI is searching for the most relevant function to complete this task. Next we use planner.createPlan async, that is the goal is equal to ask, which tells the AI to analyze the question and identify the right skill to use. Since we previously added the time skill, the planner will likely pick a function that fetches the current date. Then finally, the script prints out the selected function skill's name and function name, showing exactly which tool the AI has chosen. This ensures that the AI can dynamically pick the right function for the different types of tasks, making it more intelligent and adaptable. This code is making the AI find the best function to write the word text to a file. So first we define the question, how do I write the word text to a file? Then we print a message indicating that the AI is searching for the most relevant function to accomplish this task. Next, the AI uses planner.createPlan async goal is equal to ask, which creates it to analyze the question and find the most appropriate skill. Since we previously added the file IO skill, the planner will likely pick a function that handles the file writing operations. So finally, the script prints out the selected function skill name and the function name, showing exactly which tool the AI has chosen. So this makes the AI smart enough to dynamically select the right function for the different file-related tasks. So now we'll run this. Now this code is all about making the AI plan and execute the multi-step task automatically. So instead of just giving a single response, the AI figures out the best sequence of actions needed to complete a request. So first it imports the sequential planner, which helps the AI break down complex tasks into steps. We also load a writing related plugin called the literate friend from a directory which likely contains the functions to help with writing tasks like generating a poem. Then we set up the planner and exclude the certain built-in skills to make sure the AI doesn't use default text manipulation tools but instead relies on the custom plugin. The goal we provide is, tomorrow is Valentine's Day, I need to come up with a poem. Translate the poem to French. The planner analyzes this request and determines the best step-by-step approach, first generating a poem and then translating it into French. It then executes the steps automatically, printing out each function it used along the way so we can track the process. Then finally, the completed poem now translated into French is displayed in a clean format using Markdown. This approach makes the AI not just a text generator but a smart assistant that can plan and execute tasks dynamically, perfectly for automating workflows. So it has generated. Step 1, used function short poem. Step 2, use function translate. Then generated result from the ask. Tomorrow is Valentine's Day. I need to come up with a poem. Translate the poem to French. Then we have this one. So similarly, this code again lets the AI plan and execute the multi-step task dynamically. It loads a writing plugin and uses the sequential planner to break down a task into steps. The given goal is write a Valentine's Day poem and translate it into French. It automatically analyzed and the AI determines the best approach. The planner executes step by step, printing details like the function used, input or output variables, and the results. So if tracing is enabled, a detailed breakdown of each step is shown. Finally, the translated poem is displayed in a clean format. This setup makes the AI a smart assistant capable of handling the complex workflows efficiently. So, after the completion of seeing the power of plugins, you can set up this powerful chat application on your system by running it with a server backend web API, a front web API, TypeScript, and React. So just refer to the available GitHub resources that are available free and you will have a fully functional AI-powered chat platform running smoothly on your machine. So with this setup, you will experience a seamless interactive chat interface, making it an existing project to explore and build upon. So congratulations on completing the plugins in Semantic Kernel. You have taken a significant step towards harnessing the AI-driven automation and orchestration in your projects. So these two codes may not run sometimes on your machine because LLM's response varies, as I have told previously. So in this case, you can actually retry using the Jupyter notebook and then you are done. So now it's time to put your skills into action, experiment with the Semantic Kernel plugins, optimize workflows, and explore innovative ways to integrate AI into real-world applications. Keep pushing on the boundaries of intelligent automation and make the most of these powerful tools. Thank you for being a part of this journey and happy coding.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.